Good afternoon. Today we are discussing JEE Mains 2026, January 23rd, Shift 1. Repeat, today's discussion, JEE Mains 2026, Session 1, that is in the January session, and the date is January 23rd and Shift 1. Okay, let us start with the questions. Perfectly inelastic collision. When you read each question, you have to make some conclusion. Perfectly inelastic collision, bodies will be stick together. It is mentioned here, but even if it is not mentioned, you have to consider that they stick together, and spheres are of same material, same nature, masses 15 kilogram and 20 kilogram moving in opposite direction with speeds 10 and 30. Then rise in temperature during this collision. Okay. So this collision is inelastic. Kinetic energy will not be conserved. And surely there will not be a gain of kinetic energy. There will be loss of kinetic energy. The loss in kinetic energy will be converted into heat. We have to calculate the rise in temperature in degrees Celsius. Okay. So kinetic energy we have to calculate before and after collision. So let us calculate kinetic energy before collision. Kinetic energy before, I say initial I. So both the bodies are moving. So I have to calculate the kinetic energy of first body. Half, its mass is 15, its velocity is 10 square, plus kinetic energy of second body, half into mass is 25 into velocity 30 square. So you have to work it out. This is coming to be how much? Half 10 square. 10 square is 100 by 250. I take it out. Remaining will be 15 plus. Here how much will be remaining if I take out half and 10 square means it will be 900. 900 I had taken out 100 by 250. So 9 is remaining. 9 into 25, that will be 225. Is correct? Half into 15 into 10 square. 10 square is 100. I have taken out 100 by 250 and remaining 15. Here 900. 100 I have taken out 100 by 250 and remaining 9 into 25. That comes to be 50 into 240. So many joules. Then final kinetic energy of the system will move together. They will stick together. They will move as a single body of mass. How much mass? 25 plus 15, 40 kilogram mass. They will move together. They will stick together and move together. So we have to calculate the velocity or momentum. Whatever, if you get momentum, you can calculate kinetic energy. So we can do it systematic manner, velocity and then kinetic energy. So they stick together means their momentum will be conserved. Momentum is conserved. Momentum is conserved. So momentum of particle number 1, 15 into 10. Another is moving in opposite direction. Minus 25 into 30 is equal to the total mass is what? 40. 40 into V. So this is 150. This is 750. 750 minus 150 will be 600. I take only numerical value. 600 is equal to 40 into V. Therefore, V is equal to 0, 0 get cancelled, 15 meter per second. So I repeat once again, 10 into 15, first body's mass, other is moving in opposite direction, 25 into 30, that is 750 minus 150, 600. I take numerical value of that. Is equal to combined mass is 40 into V, that is 15 meter per second. Then what about kinetic energy final? That is combined mass. Half mass is 40 into velocity square. That will be 15 square. That's coming to be 20. 15 square is 225. Double of 225 is 450 joules. Now, loss of this is coming to be 50 into 240. Isn't this is 450? So it will be 1,200. No, 12,000. No, is this any difference? 50 into 240. This is initial kinetic energy. Final kinetic energy is half into 14 into 15 square is 2. This is 4,500. 4,500 surely. 15 square is 225. 225 into 225 into 450 into 100, 4,500. Okay. Then loss of kinetic energy. This is coming to be 240, 121, 12,000. This is coming 12,000. 12,000 minus 4,500. This is converted into heat. Now tell me, here it is given in specific heat of material is given in calories. So we have to convert it into joules. And here we are going to get the result in 12,400 by 4. That is 12,400 minus 4,500. That is coming to be 7,500. I'm correct? 7,500. Yes. 7,500 in joules is equal to, here specific it in calories, I want in joules. So what I have to do? The T1 mass is 40. 40 into specific it is 31 calories per kilogram. Therefore, 31 into 4.2. Yes, specific heat you have to take. So make it clear that specific heat is given in calories per kilogram. You will be getting heat in what? Calories and mass should be taken in kilograms. So earlier also I told you, we are not adamant about the unit system. Whatever manner we have taken specific heat or latent heat, accordingly heat will be coming, accordingly mass will be taken. Here on the left hand side, we are getting 7,500 joules. So here we have to get in joules, and similar at the same time mass must be in kilogram. So we have to take specific heat in joules per kilogram. So 31 calories I converted into 4.2 into difference of temperature. So from that, I'll be getting the difference of temperature. Answer is coming to be 1.44. Yes, you can work it out. I'm not going for the final answer. Then this is a method. There is a loss of kinetic energy. Final kinetic energy will be less. There is a loss. So initial kinetic energy of two bodies minus final kinetic energy of the combined body. For finding the final kinetic energy of the combined body, we have to find out the velocity of the combined mass using momentum conservation. Momentum conservation, once again, both the bodies are moving in opposite direction. First body, 15 into 10, 25 into 30, then we work it out, we will be getting the answer. So, completed. Method I told you, calculation part I am leaving to you. Some calculation I do here, that's another thing. De Broglie wavelength of oxygen molecule at 20. Oxygen molecule we have to consider as a particle. For a particle, energy is given, de Broglie wavelength is given by h by root of 2me. This is the expression for de Broglie wavelength. For a particle at a temperature T, its internal energy, which is kinetic energy, is 3 by 2 kBT. Therefore, your lambda comes to be h divided by 2 to get cancelled, root of 3m into kBT. So, every values are given to you. H, you have to take it as better you take convenient, most easy form you take it. Easily divisible, divided by root of 3. Mass you want in kilogram, mass of one molecule of oxygen. Here it is given. How much it is? 5.3 into 10 to the power of minus 26. Boltzmann's constant is given. You put the value. Temperature is given to be how much? 27 degree in Kelvin. That comes to be 300 Kelvin. And you have to work out the value. You will be getting the answer is coming to be x into 10 to the power of minus 12. So x is coming to be 26. X is coming to be 26, answer 2. When you work it out, answer is with you. You can verify it. But this is only nothing, no, only one thing. Energy of the oxygen molecule. Oxygen is a, you have to consider a single particle. It has got translatory motion. You have to consider its energy. That's only. That's only. Isn't it? Mass of oxygen molecule. Oxygen molecule. So, no, one thing. Oxygen molecule we talked about. It's a diatomic molecule. So, it has a possibility of what? Rotation also. So, its energy, you have to work it out as 5 by 2. 5 by 2. Make a correction, 5 by 2. It's a diatomic molecule, oxygen 5 by 2. So this comes to be 5 mkBT. 5 mkBT. Yes. Then this will be 5. Then you work it out, you will be getting the answer. Okay. Go to the next question. It's a theory question. Assertion-Reason question. Individual atoms in a ferromagnetic material possess magnetic dipole moment and interact with one another in such a way they spontaneously align them forming. That is domain theory of ferromagnetic materials. There are two aspects. Each ferromagnetic atom has more unpaired electrons. Compared with the paramagnetic atom, the magnetic moment of each atom is more. In addition to that, few such atoms are aligning in same direction, forming a region of very high magnetic moment that is called as domain. So, domain theory is applicable in the case of ferromagnetic materials. So, domain has two aspects. Each individual atom's moment is very high in compared with the paramagnetic atom. In addition to that, few ferromagnetic atoms arranged in same direction, forming a region of large magnetic moment. So instead of atomic dipoles, your domains are getting aligned. So first statement is very correct. Whereas second, say high temperature, domain structure of ferromagnetic material disintegrates and slowly it will be losing its ferromagnetic feature. That is also true. But the second statement is correct in its own way, but it is not supporting what the first statement. It is not supporting the first statement. So your answer is both assertion and reason are true, or is not the correct explanation of it. Next one, in a screw gauge, zero of the circular scale is lies 3 divisions above the horizontal, above the baseline. Means if 0 is below the baseline, you might have studied when 0 is below the baseline, that is 0 is ahead. 0 is ahead. So it is positive error. Positive error. Here 0, it has not reached 0. 0 is lagging. 0 is behind. So error is negative. First point, error is negative. So how do you identify it? Normally diagram will be given. In the diagram, it will be like this. Suppose this is the baseline, only 0 is visible. Look, yes. This is the 0. 0 is ahead by 3 divisions. How many divisions? 3 divisions. This is negative 0 error. And negative 0 error is that error division multiplied by the least count. Error division is -3. Least count is given to be 0.01. That is minus 0.03 millimeter. Then pitch scale reading is 1 millimeter. So your pitch scale reading, main scale reading is 1 millimeter and coinciding division is 51. Therefore, total reading will be main scale reading 1 plus circular scale reading. That is 51 into 0.01. 51 into 0.01. That is coming to be 1.51 millimeter. Then correct reading is total reading plus 0 error. But within condition, 0 error is always subtracted with sign. 0 error is always subtracted with sign. So total reading is 1.51 minus of minus 0.03. So minus of minus will become plus 1.51 plus 0.03, that is 1.54 millimeter. Yes, so this is the answer in millimeter. So you have to make the conclusions first. That is, normally diagram will be given. Diagram will be like this. 0 is, this is the pitch line, plumb line, baseline. 0 is above the baseline. Means 0 is lagging. How many divisions it lacks? 3 divisions. 0 is 3 divisions above. So what will be happening? It will be negative 0 error. Negative 0. So this will be 97. This will be corresponding to 97. This is 95, 97. So how many? We are not taking this reading. Error division, negative error division is how many divisions? 0 above the baseline. That is given to be -3 into least count. So 0.03 minus 0.03. Then total reading, pitch scale reading plus circular scale reading. That is directly given as 1.51 millimeter. Then correct reading is total reading, total reading minus 0 error. Error is always subtracted with sign. Minus, I written minus here. Error is always subtracted with sign. That is the rule. Error is always subtracted with sign. So, error will be minus 0.3. Minus of minus will become plus. So, we'll be getting 1.54. Okay, we go to the next question. Pendulum string length 30 centimeter performs 20 oscillations in 10 seconds. The length of the string required for the pendulum to perform 40 oscillations in. So this is a problem related with the time period and length or frequency and length. But we are more familiar with the period. So let us write the formula for period. T is proportional to root L. We want the length of the pendulum for string to make 40 oscillations. 40 oscillations. So here T dash proportional to root of L dash. Therefore, T dash by T is equal to root of L dash by L. So your problem, the first step you have to write like this. You have to identify that this is a problem of time period related with the length or frequency related to the length. But we are more familiar with the time period. Therefore, we write T proportional to root L. So directly we can write, don't write all the things. For explanation, I written it directly I can write. Now, this is the first point. Second point, you have to make thinking. Here, first case, it makes how many oscillations? 20 oscillations in 10 seconds. And it has to make, required to perform 40 oscillations in the same time. Number of oscillations has become what? Number of oscillations has, we can either, or we can calculate the time period. 20 oscillations, 10 seconds. Therefore, 1 oscillation's time, that is time period, that is 10 by 20, that is 0.5. Second case, T dash, how many oscillation? 40 oscillations in how many? Therefore, time for 1 oscillation is, isn't it, number of oscillations? No. Isn't it 20 time period is time for 1 oscillation. So for 20 oscillations, 10 seconds, therefore 1 oscillation, 10 by 20 point. 40 oscillations, same time, 10 seconds. Then to perform 40 oscillations the same time, time is still 10 seconds. That is 10 by 40. That comes to be 0.25. So we have to make count the time period. Simple calculation. 20 oscillation, 10 seconds. 1 oscillation, that's a period, 10 by 20. That is 0.5. 40 oscillation, 10 seconds. 1 oscillation, 40 by 10 by 40. That is 0.25. Now, we can directly come over here. T dash is 0.25. 0.25 divided by 0.5. Root of L dash you have to calculate. L is 30 centimeter. Quantity, this is 1 by 2. Quantity within root is, we have to square it. So you have to square, this is 1 by 2. 1 by 2 square is 1 by 14. L dash by 30. Then L dash coming to be 30 by 4. That comes to be 7.5 centimeters. So direct question. So we need not even spend this much time. We can directly, okay. Good afternoon to everybody watching me. Okay, come on. Now, this is a direct question, and you have to make out this problem with time period and length. That is the thing. Next question. This is a question of Zener diode. Isn't it okay? What things are given to you? Yes, Zener voltage, we write VZ. VZ is 5 volt. Okay. Now, voltage across the load, that is VO. VO is also is equal to VZ, that is also 5 volt. Then next is given, this reside a current, load current. Load current we write IL. IL is given to be 5 milliampere. And it is given that the Zener diode can withstand 4 times the load current. 4 times the load current. Therefore, Zener current is 4 into 5, that is 20 milliampere. So these are the informations given to you, that is 20 milliampere. Okay, one thing we have considered that this is the current coming. Yes, then this is the main current I call I. This is Zener current IZ. This is the load current I call IL. I got IL and IZ. So automatically I will be getting I is equal to, IZ plus IL. That is 25 milliampere. That's the current through the resistor. Now tell me, we have to calculate what the value of the resistor are. We can maximum regulated voltage. Regulated voltage is maximum. Maximum will be the voltage across series resistor, but voltage across the voltage across the Zener diode or output voltage or load voltage, that will remain same, isn't it? Any variation in unregulated voltage comes, that is being suffered by the series resistor. The series resistor is doing the duty of a shock absorber. Variations in variations in this is being suffered by the series resistor. Okay, so here it is told that maximum Zener current is 20 milliampere. So load current is maximum. Therefore, voltage across the unregulated supply is maximum. Voltage across series resistor is maximum. Now, what about the voltage across series resistor RS? How much? You know, this is unregulated voltage VUN minus Zener voltage, because Zener voltage and load voltage are same. This is coming to be unregulated voltage is 25 minus Zener voltage is given to be 5 volt, that is 20 watt volt. So voltage across series resistor is 20 volt. Current through the series resistor is 25 milliampere. Therefore, series resistor. So value of series resistor is equal to voltage across series resistor divided by the current I. Voltage across series resistor is how much? 20. Then current is how much milliampere? Total current 25 milliampere. 25 into 10 to the power of minus 3. Therefore, 20 by 25 into 10 to the power. Your answer is given in what unit? Ohms. This is in ohms. This is 10 to the power of 3. This is coming to be 8. This is 4 by 5. So this will be 40. 40 into 20, 800 ohms. I think that answer is not given here. 800 ohms is the answer. Answer is not given here. 800 ohms answer is not given over there. I think so. This is, yes, 800 ohms answer is coming to you. Correct? So this is the way we have to do it. Now, one thing, this can vary. Unregulated voltage can vary. If unregulated voltage changes to say some 30 volts, accordingly, the voltage across series resistor will be changing. Okay, but low Zener voltage, which is equal to the load voltage or output voltage, that will remain same. For any arrangement using this Zener diode, output voltage will be the Zener voltage, that will remain same. According to the unregulated voltage variation, the changes in voltage will happen across series resistor. Okay, so answer here it is 800. Note that. Now tell me, there are two charges kept, one at vertex, that is 2q, other at flex is a scalar quantity. So we have to simply add algebraic sum of flex, because flex is positive flex and negative flex. Here both the flex are emerging out. We have to calculate the total flex emerging out. So both the flex are to be added. Because it is a scalar quantity, you don't worry about the direction in which flex, because it's scalar. Therefore, we have to calculate the total flex. Total flex is equal to flex due to 2q charge plus flex due to q charge. That's the first point. Both flex will be added up without any direction, simply algebraic sum. Why do I mean by the word algebraic sum? Flex may be either emerging out or flex may be entering. Emerging flex is taken as positive, entering flex is taken as negative. So here both flex are emerging. Now we have done a charge is kept on the corner of a cube. We are told in the class so many times. Flex through the 2q will be 1 by 8 into 2q by epsilon 0. I'm not repeating. We have done a number of times in the class. If a charge is kept the corner of a cube, we have to imagine 8 such cubes so that this charge 2q will be at the symmetric center. So flux will be 2q by epsilon 0. That total flux will be equally distributed through the 8 flux. Now, what about flux through the charge q? Charge q is kept at the center of a face. To make it symmetric, we have to think about one more cube placed in contact so that this charge q will be at the symmetric center. Then only you can apply the Gauss's theorem. In order to facilitate Gauss's theorem application, we are imagining one more cube kept close to it. Both the cubes together, the charge will be at the symmetric center. So total flux will be equally shared by both the cubes. So flux will be 1 by 2 into q by epsilon 0. This is coming to be q by 4 epsilon 0. This is coming to be q by 2. So 1 by 4 plus 1 by 2 will be 3 by 4. The total flux will be 3 by 4 into q by epsilon 0. Answer is very much there. Third, this is the answer. Okay. So this point you have to consider. Whatever may be the charge, contribution due to each charge flux will be algebraically added separately. Okay. We go to the next question. Now an object is projected at kinetic energy k from at A at an angle 60. The angle of projection is, so again no, angle of projection is 60 degree. Kinetic energy of projection is a k0. K0 is k. That is initial moment. That is a k0 we call. And we have to calculate the ratio of the difference in kinetic energies at this point B and C. B is at the topmost point, C is at the bottommost point. And to that top point, we have to find the ratio of what? We have to find the ratio of kinetic energy at C, difference of kinetic energy at C and B to what kinetic energy? The kinetic energy at A. This is we have to calculate. Difference between the kinetic energies of A and B, kz minus kb divided by kinetic energy at A. But we know initial kinetic energy is k, that is at A, kinetic energy at A. Better to write Ka, initial, better to write kinetic energy at A. But we know that is K. This will be same as that of the kinetic energy at C. With what velocity body is projected, same velocity body hits the ground. No mentioning about energy loss, isn't it? Even in the absence of air friction. And they need not mention about it. If air friction is there, we cannot make a calculation. So if no mentioning about air friction, it is understood that we don't mind it in the absence of air friction. So kinetic energy at A is equal to K is equal to kinetic energy at C. Then we have a ready-made formula. Kinetic energy at B is equal to K into cos square theta. That is K into cos square 60. Cos square 60 is 1 by 4. That is K by 4. So now tell me, we have to calculate the ratio. Kinetic energy at C, that is K. Kinetic energy at B is K by 4. Kinetic energy at A, that is K. This is 3 by 4K divided by, that is 3:4. The answer is coming to be, answer for the question of 8 is, answer for the question 8 is 3:4. 3:4 is the answer. Okay? Yes. B is the answer. Simple question, direct question. You can save time. So utilize this type of questions. Now tell me, consider a light traveling from a medium A to B is plane interface. Light undergoes total internal reflection during its travel from A to B. The speed of light in A and B are 2.4 and 2.7 respectively. Then value of critical angle. Therefore, refractive index, and what refractive index require? Rarer to denser. Rarer to denser mu. That is normal mu. Mu rarer to denser mu. That is velocity in rarer to the velocity in denser. Velocity in rarer, how do you identify? Here, A's speed is less, B's speed is more. Isn't it? So, B is rarer medium. Velocity in rarer medium is 2.7 into 10 to the power of 8 divided by 2.4 into 10 to the power of 8. That comes to be 9 by 8. Here, light ray going from this is, or I can also write, this is the refractive index of what? Light ray coming from where to where? B to A. Refractive index of B, A with respect to B, because A is denser medium. Light is coming from the, but mu you want what? Rarer to denser medium. That we want. Come on. Once again, in calculations when mu is coming, here in our problem, this is a critical angle problem. Light ray going from A to B, A is a denser medium. Speed is less than in denser medium. But when you calculate the refractive index, you want the normal refractive index, rarer mu D. That is, the error is B, B mu A. That is 9 by 8. Correct? Now, what about, we have to calculate what? The critical angle. Sin C is equal to what? 1 by rarer mu denser. That is 8 by 9. So, C is sine inverse 8 by 9. And one thing we know that it cannot be 9 by 8. It cannot be a number more than 1. Sine or cosine value of any angle, it should be less than 1. So, look whether we have the answer. No. We have cos inverse 8 by 9. No sine inverse 8 by 9. So, okay, we don't neglect to try. How do you try it? Just easy way to this. Here, sin C, or we can say sin C is 8 by 9. We have written it, sin C is 8 by 9. Let us write this is C. Sin C means opposite side by hypotenuse. Opposite side is 8, hypotenuse is 9. Therefore, this will be root of 9 square plus 8 square. That is 81 minus, that is root of 70. Now, can I make, from here, can I make tan C? Tan C is equal to 8 by root of 70. Is it correct? Is it correct? Because since other functions are, I can try cos also, no problem. I can try cos C, or I can try tan C, whatever I try. Let us check whether answer is there. Tan C is coming to be opposite side by adjacent side. That is there. What about cos C? Root of 17 by 9. No such answer is there. So tan C is root of 8 by root of 17, or C is equal to tan inverse 8. That answer is there. From the first pick, we are getting what? From first pick, we are getting sin C is equal to what? Sin C is equal to, we are getting 8 by 9. Or C is equal to sin inverse 8 by 9. That answer is not there. So just have a look into it. From sin C, we can calculate cos C or tan C. So try for that. Just have a look into it. Don't leave the question by saying question is wrong. Try for other options. You have sin C, you can go for tan C, and we got it, tan C, tan inverse 8 by 7. Go to the next question. Then moment of inertia of a square loop of solid cylinders, each having radius r, length LR is less than L, about an axis through midpoints. So we have to, yes, I'm going to draw the diagram. Some calculation. These are not thin rods. These are what? Cylindrical rods. Cylinders. Yes. 4 cylinders. They are identical cylinders. 1, 2, 3, 4. We have to calculate moment of inertia about an axis passing through the midpoint. Isn't it? This is our axis. This is its center of gravity axis. These two rods. This is center of gravity axis of this rod. This rod. I drawn different axes. I drawn to it. You have to calculate the total moment of inertia of. First, I calculate this is, I number it 1, 2, 3, 4. You have to find, my question is this, I is equal to I1 plus I2 plus I3 plus I4 about the common axis. All the 4 moment of inertia to be found out, all the 4 moment of inertia to be found out about the common axis. That is I1 plus I2 plus I3. You have to calculate the common moment of inertia. Now look, from diagram it is, we are easy to say I1 is equal to I2. Both are equal. I1 and I2 are equal. Okay, so that's some easiness in our calculation. I1 is equal to I2. What is that? I want about this axis, but this axis is its central axis. Means it's a central axis. Okay, so you know the moment of inertia of a cylinder about its central axis, and use parallel axis theorem. What is that? I1G plus M D square, isn't it? And here we have to calculate so better you take the total mass of the loop is M. So mass of each rod, I have to take it as what? M by 4. So better you deal with small m, and in the final step, you can substitute, replace small m by capital M by 4. So for time being, I use mass of each individual rod. The entire loop's mass is capital M. So this is I1G plus MD square. Come on. I1G is moment of inertia about disk about its own axis. What is that? That is M capital R squared by 2. This rod about this axis. M squared by 2. Then plus M. D is what? How much? It is given in the diagram. No, it's not going. You have to make it out. This is total length of each rod is L. L is a rod. This is L by 2. This is L by 2. Correct? So this will be M L square by 4. Correct? So M R squared by 2 plus ML square by 2. Let it be there. I got both I1 and I2. Correct? Now, what about I3 and I4? They are rotating about an axis. This is the axis I want, but if you can see, they are rotating about an axis like this. Isn't it? About an axis passing through the center and perpendicular to the axis. So their moment of inertia is for I3 is equal to I4 You know, this is the axis. When you are rotating the whole arrangement, this rod is rotating about an axis, passing the axis, the mentioned so-called axis is passing through the center and perpendicular to length. We have a diskwise aspect is there, as well as what? Diskwise aspect, what? Disc rotating about a diameter. What is that? M r squared by 4. Because there is this axis is, when I can calculate, it's rotating like this. Axis is passing along its diameter. So m r squared by 4 plus passing through the middle of the rod. That is coming to be m l square by 12. Okay. So this is the moment of inertia of these two rods, I3 plus I4, about the common axis. All I1 and I2 I have taken about the common axis. I3 and I4 I have taken as common axis. I1 and I2 are equal. That is, you have to use the parallel axis theorem. I1 G plus MD square, D is L by 2, and MR squared by 2, it is rotating about its central axis, plus parallel axis theorem I am using, ML square by 4. Therefore, total moment of inertia will be, once again I am adding I1 plus I2 plus I3. I1 and I2 are equal, so it is coming to be 2 into, I1 and I2 are equal, 2 into, what is that? MR squared by 2 plus how much? ML square by 4. 2 into plus 2 into MR squared by 4 plus ML squared by 12. Yes. So I have added the, why I am multiplying it to each rod's contributions. I1 and I2 are equal, so we have to double it. I3 and I4 are similar, I have to double it. So it will be 2 into I1's is what? This is I1's, MR squared by 2 plus ML squared by. This is I3 and I4, MR squared by 4 plus ML squared by 12. So now tell me, well, adding it, I will be getting how many? We have to combine MR squared to be combined. MR squared by 2 MR squared. So this will be, how much it will be? This will be MR squared. This will be MR squared by 2. This is coming to be 3 by 2 MR squared. Correct? Plus, this is ML squared by 12. This is ML squared by 6. ML squared by 2 plus ML squared by 6. How much it will be coming? ML squared by 2 plus ML squared by 6. Am I correct? ML squared by 2 plus ML squared by 6. That is coming to be, multiplying 3. 3 plus 1, 4. 4 ML squared by 6. Correct? This is 2 multiplied 3. 3 plus 1, 4. That is 4 ML squared by 6. But my answer I want in terms of what? Capital M. And in the beginning we written small m is capital M by 4. So we have to change it capital M. 3 by 2 into capital M by 4 r squared plus 4 by 6 into capital M by 4 L squared. Let us see whether answer is coming or not. 3 by 8 MR squared plus 4 get cancel ML squared by 6. 3 by 4 MR, yes, we have answer very much there. Calculation, not mistake came. It is second or third option is coming. 3 by 8, sorry, not this option. Not this option. 3 by 8. This option is coming. Third option is coming. 1 by 6. So some calculations are there, but calculation has a rhythm is there. I1 and I2 are equal, so only calculate I1. I3 and I4 are equal, but you have to make out that some imagination is required. I1 and I2, we want an axis use parallel to the central axis. So I had to use parallax theorem. I got I1 or I2 is equal to mr squared by 2 plus ml squared by 4. But I3 and I4, it is rotating about an axis passing through the center. We have ready-made formula for that. What is that? Mr squared by 4 plus ml squared by 12. Then we added it, all the 4. Then last we made a change. Instead of capital M, small m, we written capital M by 4. You got the correct answer. We go to the next question. 3%. So this is, I'm not doing it. This is relative error calculation. We have to find the average. Method is that find the average. L1 plus L2 plus L3 plus L4 by 4. Then find out each delta L1, delta L2, delta L1. Isn't it? Then we have to calculate average relative error. While calculating average relative error, we have to add it. Even minus coming, you have to add it. Okay, we know it. I'm leaving to you. Answer you might be knowing. Answer is coming to be 2. I'm not doing that simple calculation. Next question. 2 blocks of masses 100 gram and 200 gram are attached to the ends of a string ABC in the figure. Energy stored in the springs A is E. Then energy stored in B when the spring constants Ka, Kb of A, B respectively satisfy the relation Ka 4 Ka is equal to 3 Kb. Now I want the energy. Energy's formula. What is that? E, kind of energy of A. That I write EA is equal to half Ka into Xa square. Isn't it? So you can calculate Xa separately and you can calculate the energy. But one easy method I'll tell you. Look, what is that? Ka into Xa whole square divided by 2 Ka. Am I correct? That is, once again I'll write it clearly. Half is there. I made a change here. What change? I taken Ka Xa square. So 1 Ka has come in excess divided by Ka. You got it? So that is given to B. So I am going to write what is E. Half into Xa Ka. What is Xa Ka? Xa Ka is the force applied on whom? Applied on the block A. K into X is the restoring force. Restoring force is the applied force. Ka Xa is the restoring force developed in A. That is the restoring force. How much it is? We can write 100 G. G acceleration due to gravity. It means CGS, no problem. We are going to do 100 G. Okay. Therefore, it will be half into how much? The Kx is extension restoring force. Restoring force, that is 100 G square divided by what? K. Let it be Ka. Finally, we can substitute. Now I can directly write EB, energy of B, half into what is the restoring force developed in the, that is 200 G square divided by Kb. I want the value of what I want. I want the value of, so EB by E. EB by E. Half get cancel. What will be coming? 200 G by 100 G whole square coming. Then K will go to the numerator. Ka by Kb. Correct? This is EB by E is equal to dividing this. So this adjustment will be useful for you because we are directly given the force pulling it down. Kxa is the force pulling it down, Kxa. So from this format, I change into this format. We can easily write it. So it will be half into restoring force square by Ka. So I have directly write it. Now 200G by 100G, whatever unit it may be, it will be 2 square into, from here I can get Ka by Kb. You can directly get Ka by Kb is equal to 3 by 4. From here you get it. Ka by Kb is equal to 3 by. I want Ka by Kb. That is 3 by 4. So this 4 get cancelled. Answer is that Eb is equal to 3E. Eb is equal to 3. Answer is 4. Eb is equal to 3E. Okay, we get the answer. Come on. Now we go to the next question. What is that? Angle of second prism produce dispersion without deviation. So total deviation should be 0 or deviations are equal. So I can write mu1 minus 1 into A1. There's a minus sign. Minus sign, it means they have to keep in opposite manner. So we don't put the minus sign. Minus sign, there is a meaning for that. Prisms have to be kept in opposite way, is equal to mu2 minus 1 into A2. Just I substitute, final answer you do it. Mu1 minus 1, 1.72 minus 1.72 into 5 degree is equal to mu2 minus 1 is 0.9 into A2. So you can work out the value of A2, no need of any teacher. Answer is coming to be 4 degree. Then we go to the next question. Next question. Now, is it clear? Oh, let us write. It's not clear. I cannot read it. Okay, we leave it. Let us do some other day. It is not clear. Question paper also, it is not clear. So we leave it. It's not clear. So we go to the next question. It's not clear. I thought it will be clear here. Now tell me, strain is on y-axis. So Young's modulus is stress by strain. And what is stress by strain? 1 by slope. Young's modulus is 1 by slope. So what is the meaning of that? One having more slope will have minimum y. One having minimum slope will have maximum y. First, normally we are marking stress on y-axis and strain on x-axis. Here you have marked just reverse manner. So Young's modulus will be stress by strain. That is the reciprocal of the slope. One having more slope will have minimum y, one having minimum slope will have maximum y. So CS having minimum slope, C will have maximum Young's modulus. We can go to the next question. Tell me, yes, read the question. We have to do the problem in 2 stages. 2-3 stages are there. Okay. First of all, I'll teach you one thing. Pendulum is pendulum A is taken through an angle theta. Theta is 60 degree. I will put it later on. Tell me, you can find that this is the height of the pendulum bob above pendulum B. Height of the pendulum bob above pendulum B. Is it so? Okay. Yes. This is length L. This will be L cos theta. In this triangle adjacent side. Therefore, height of the pendulum bob is a very basic information. L minus L cos theta or L into 1 minus cos theta. This is the first information you require. When the pendulum is tilted through an angle theta, if L is the length of the pendulum, height through which it has gone is L cos theta. Number one. Number two, on releasing it, when it reaches when A reaches equilibrium position, its velocity of A at equilibrium position is, you have to equate the energy. So what is that? It has got kinetic energy half mVA squared is equal to mg into h. H is L into 1 minus cos theta. Therefore, m get cancelled. We are getting velocity of A on reaching equilibrium position is VA square, I can write. VA, root of 2GL into 1 minus cos theta. This is second information. So when pendulum is released, when it reaches the bottom, the velocity it attained is root of 2GL into 1 minus cos theta. Number three, both mass of A is equal to mass of B. So collision is elastic. They interchange the velocities. They interchange velocities. Isn't it? Now, B will start moving with the velocity of A. B will start with the velocity of A. How much velocity of A? We can calculate it. Root of 2G. What do you have to calculate here? The value of R. Length how many meter? Length 1 meter. Into 1 minus cos 60. Cos 60 is half. Isn't it? Therefore, velocity of A is coming to be root of 2GL. That is 2. 1 minus cos theta is half. That is root G by 4. Root of G by 4. Now, this is the velocity of B. Now, with this velocity B reaches here. This velocity B, it reaches here at the bottom of the circular track. What is told that, and the Bob just managed to complete circular path. This is to move in a circular path of radius R and reach the point Q, means it should complete the vertical circular path. So what is the question asked you? B is kept on a smooth horizontal surface, no change of velocity, and then entering into a circular track. We just manage means it is coming with minimum velocity of radius R up to the point Q. It should complete the full vertical circular motion. So its velocity should be, in order to complete the velocity, its velocity should be root of 5GR. So this is the fourth concept. Now by equating it, what get cancelled? G get cancelled, root removed. We'll be getting R is equal to G get cancelled 1 by, no. Any mistake. Velocity is root G into 1, root of 5GR. Velocity at the bottommost point of root of 5GR. This is root of G by 4. Root removed. Velocity of B is R is equal to 1 by 5. Not 1 by 20 is coming. Any mistake happened here? Nothing. Answer is coming. What answer is given? Okay, coming to be 1 by 5. 1 by 5. Any mistake happening? Root of G by 4. Velocity is coming to be 2 into G into L is 1. 1 by 1 minus cos theta is to the G by 4. That is 5 by 20. In what unit they are given? Oh, in meter. Meter is correct. It's still in meter. Mass M is attached to the massless rigid rod of massless rigid rod at a point P and making an angle of 60 degree with the vertical rod. The distance 1 meter below the point. An identical bob is kept at rest on a smooth horizontal surface to a circular track of radius r. Bob is just managed to complete. So this is the idea. You have to calculate the velocity. They will be identical mass, collision elastic. They will interchange the velocities and same velocities reach here just to keep a circle. So some mistake came in that. Okay. So this will be now some mistakes will come. Root of 2GL. Velocity half m e squared V a square is equal to, yes, 1 minus cos theta root of G by L, the root of 5 GR. And we have to calculate what? Radius R is equal to 1 by 20. It's 1 by 5 coming. Any mistake or side. Track of radius R as shown in the figure. Okay, we'll do it later. I got correct answer. Then where the problem came, I don't know. We just managed to complete a circular path of radius up to the point Q. So velocity at the bottommost point should be root 5 GR. We got root of G by 4. It removed the root. Then 4. 1 by 20. I got 1 by 5. R's value is 1 by 5. Angle with vertical as shown, distance of 1 meter below the point P. It's correct. This is P 1 meter. As a distance of 1 meter, it will be, and pendulum bow smooth over surface to extend the circular track. Identical bob kept at resistance. Elastical hitting elastic. So they interchange the velocities. The interchange B will have a velocity of this root of 2GL into 1 minus cos theta. So everything clear? This is 1 minus cos theta is 1 minus 1 by 2 half. Oh, we made a mistake. Yes, look here. What is this? This is not 1 by 4. This is coming to be simple calculation root of 2GL into 1 by 2. 2 get cancelled. It is root GL, not G by 4. That is our mistake, isn't it? This is root GL. So root GL, L is 1 meter. That is root G. Therefore, what is this? It's a very direct question. So I think answer cannot be wrong. I was thinking like that. VA is root GL, L is 1. So this is coming to be root G. So here we made a mistake. Why? I took half. So I take 1 by 4, not 1 by 4, 2 and 2 get cancelled. So it will be root GL. L is 1 meter. That is root G. So root G is root 5 GR. Therefore, R is coming to be 1 by 5. Yes, answer is very much there. So some careless mistake came over there. We have to be very presence of mind. Simple half, instead of taking half, we have taken 2. That is the problem. So it is okay, clear, very simple problem. We go to the next question. Now, 2 balls of mass M and M are attached to the ends of a rod of length LD and negligible mass. So we don't consider the rotation of the rod. Angular moment of the system is L about an axis A passing through the center of mass perpendicular to the rod. angular velocity of the system about A, isn't it? So it is given that angular momentum of the system is L. We have to calculate the angular velocity. We have to calculate it. Okay. Now this is the rod. And this is the axis of rotation. Okay. Come on. This is mass M. This is mass 2m. This distance is d1. This distance is d2. This is the axis passing through the center of mass. And we know if you take distances d1 and d2 from center of mass, we have formula m1 d1 is equal to m2 d2. Therefore, m1 is m into d1 is equal to m2 is 2m into d2. That gives you d1 by d2 is equal to 2 is to 1. We know that distance of the center of mass will be away from the lighter mass or nearer to the lighter mass. So this correct d1 by d2, it will be nearer to 2m. That will be, I have to draw it like that. It will be nearer to this thing. Nearer to this one. Therefore, this is d1, this is d2. Oh, question has gone. Yes. So better I draw this diagram a little bit. Okay, now I made it bigger. This is small m. This is 2m. This will be d1. This will be d2. We got d1 by d2 is equal to 2. Now we have to calculate the total angular momentum of the system is L. What will be the total angular momentum? Moment of inertia. So it will be, we don't consider the moment of inertia of the rod, this point mass. So it will be I1 omega 1 moment of inertia of this rod. Momentum in, we have to calculate what? The velocity of the angular velocity of the system about A. So they are rotating with same angular velocity because they turn same angles in same time. So it will be d1 by d2 is equal to O. Okay, so I'm leaving the diagram and writing it. Distance d1 by d2 is equal to 2. d1 by d2 is equal to 2. Okay. Now tell me, the total length of the rod is d. Therefore, this gives you d1 will be divided in what ratio? 2:1, 2 by 1. d1 will be 2/3 of d and d2 will be 1/3 of d. This will be 1/3 of d. Okay. Then you have to calculate the angular velocity of the system. Then it's a point mass. You have to consider the point mass. So moment of inertia, first one will be m1 d1 square into omega plus m2 d2 square into omega, m2 d2 square into omega. That is a point mass is equal to the total angular momentum. I1 omega, because both are having same angular velocity, they turn same angle in same time, both will have same angular velocity. I have to calculate the value of omega. M1 is M. D1 is how much? 2 by 3D, that is coming to be 4 by 9 D square. Plus omega, I can take it out later. M2 is 2M. D1 is 1 by 3. 1 by 3 square is 1 by 9 D square. Whole into omega is equal to L. So this is coming to be 4md square by 9 plus 2md square by 9. So that is coming to be 4 plus 2, 6md square by 9 into omega is equal to L. This is coming to be 2 by 3. Therefore, omega is equal to 3L by, this is 9, this is 2. So, omega will be 3L divided by 2md square. Yes, 3L divided by 2md square. Answer is this. Okay, direct question. Now we go to the next question. 18th question. Now, wire of resistance lambda per meter resistance. Now, we have, let us call this portion as some ACB to identify. I put one more C. We have 3 portions, isn't it? 3 portions. All 3 portions are connected between the points A and B. That's the first information. First information. All the 3 portions are connected between A and B, between the point. That means all the 3 portions are parallel to each other. Let us calculate the resistance of each portion. RAB, resistance of AB. It is circle of radius R. This is a quarter of circle. Its length will be pi r by 2. How much per meter resistance? Lambda. Therefore, this is coming to be pi r by 2 lambda. That is AB portion. Next, AOB portion, this one, AOB, RAOB, that is total length 2R, resistance will be 2R into lambda. And third portion, resistance of ACB branch, its length is 3/4 of 2 pi R or 3 pi R by 2, 3 pi R. So that comes to be 3 pi R by 2, 3 times this, because this is pi R by 2, this is 3 times length is there into lambda. So we have the resistance of 3 portions and all the 3 portions are connected parallel to each other. Now tell me, what is 1 by R effective? 1 by RAB plus 1 by RAOB plus 1 by RACB. 1 by RACB. Now tell me, 1 by R effective is equal to, how much it will be? 1 by RAB. Who will go to the numerator? 2 divided by pi R lambda plus then 1 by 2R lambda plus 2 by 3 pi R lambda. So we can do one thing, something common we can take it out. 1 by R effective. What is common? R lambda is common. R lambda is common, correct? R lambda, 1 by R lambda I have taken out. 1 by R lambda I have taken out. What is here? 2 pi. What is here? 1 by 2. What is here? 2 by 3. R lambda is 2 by 3 is remaining. R lambda is given. 2 by 3 pi is remaining. Okay. Then we can take the LCM. 1 by R effective is equal to 1 by R lambda What about LCM of this? We have 6 pi. 6 pi. 6 pi is the LCM. Then 6 by pi by 6, that is 12. 12. Then how much will be remaining here? 6 plus how many? 2. 2 plus 2, 4. 4. LCM I have taken as 6 pi here dividing. 6 will be there. 6 into 2, 12. Plus 1 by 2, dividing by 6 pi will be 3. 3 pi will be there, correct? Plus how much will be there? 4 will be there. 4 plus 2, 8. So 1 by R effective is equal to 1 by small r lambda. This is 12 plus 20. 20 plus 3 pi divided by 6 pi. 20 plus 3 pi, isn't it? Divided by 6 pi. So calculation is coming. Okay, let us check it. Check it. 1 by r effective, that is 2 pi. Let us 12 plus 3 pi plus 6 pi. 6 pi is the LCM, correct? 6 pi is the LCM. Then 6 pi, the 6 plus 6 into 2, 12 plus 4, 2 into 2, 4 only. This is 6 into 2, 12. 12 plus 4, 16. 16 plus 3 pi. 16 plus 3 pi divided by 6 pi. 1 6. No. So R effective will be R lambda 6. Yes. Reciprocal is that. R effective is that 6 pi R lambda divided by 16 plus 3 pi. Yes. Answer is very much here. Okay. It's not a difficult question. We go to the next question. Now, a uniform copper wire held horizontally allowed to fall under gravity through a horizontal magnetic field of 0.5. So we'll write one quickly. Magnetic field is 0.5 goes 0.5 into 10 to the power of minus 4 Tesla. Isn't it? G we have taken it as 10. Then perpendicular to the length of the wire, induce him across the wire when it travels a distance of 200 meter. A length of the wire is 20 meter. Yes, induced EMF we have to calculate by BLV. We have to calculate velocity of the rod when it is coming down through a vertical distance of velocity is given by root of 2 into G into H. That is coming to be 2 into G is 10. This is 200. That comes to be 420 root 10. Am I correct? That is 400 root is velocity is 20 root 10. Then induced EMF will be, what is B? 0.5. L is 20 meter into velocity is 20 root 10. So this is 10. 10 into 20, that's coming to be 200 root 10. 0.5 into 20, that is 10. 10 into 20 root 2, induced EMF is coming to be 200 root 10. And into, how much is there? B, 0.5 into 10 to the power of minus 6. That many volt. So in millivolt, we have to multiply with 1,000. So this is coming to be 0.2 root 10. I think answer is coming to be 0.2 root 10 millivolt. 0.2 root 10. This is 10 to the power of minus 4, not minus 6. Minus 4. So I'll write here. This is 0.5 into 10 to the power of minus 4. This is 10 to the power of minus 4. So your answer is coming to be 200 root 10 into 10 to the power of minus 4 in millivolt. But to multiply with 1,000, this is coming to be how much? Into 10 we have to multiply. So it is coming to be how many millivolt? That is 20 root 10 millivolt. Isn't it? 28 root 10 millivolt. Okay, that is there. Next question. Then hydrogen atom spectrum are Rydberg's constant. We have already discussed Lyman series and Balmer series, and maximum wavelength of radiation. That is a correct statement. I think this is a correct statement. Then Balmer series lies in the visible region. Actually, to some extent, we can take it. It's partly visible, partly ultraviolet, but we can take it mostly in visible region. We can take it like that. Then minimum wavelength of radiation of Paschen series is that's 9/4. So A, B, C are correct. Only D is wrong. We want that only. Now we're coming to the fill up the blank numerical types. Simple pendulum made up of mass wire metallic wire of length 10 centimeters suspended vertically in a uniform magnetic field of 0.3 Tesla. Magnetic field direction is perpendicular to the plane of the lobe. It is tilted from an angle 30 degree, the vertical, then maximum induced EMF between the points of suspension and it. Okay. Now tell me, this is a metallic conducting wire. This conducting wire, when this is a case of just like a rod rotating about one end. Rod rotating about one end, that is between A and B. There is an induced EMF developed. We have ready-made formula, half B L square omega. Half B L square omega. Okay. So B we have how much? We have the B 2 Tesla. We have the L, how many? L will be 10 centimeter or 0.1 meter. Okay. We have to calculate omega. Omega we don't know. How to get omega? Omega of each and every point on the rod will be remaining same. Omega of each and every point on the rod will be remaining same. Omega. Isn't it? But its linear speed will be different. So we can calculate the linear speed of the point B when it reaches the where what is asked to you. Pendulum is released at an angle theta, then maximum induced EMF between the point of suspension and this point, that is O. So we have already studied that. This is length of the pendulum and this is the height h, and we have calculated velocity of that, how many? The 10 gram mass, velocity of 10 gram mass, that is at the end point. On reaching the point O, we have root of 2G L into 1 minus cos theta. We already used it. 2G. G we can take it as 10. Length is 0.1. 10 centimeter length. This is going to be 10 centimeter of 0.1 into 1 minus cos theta as usual 60 degree. Half is coming. This is coming to be 2 get cancelled 10 in, that is root 1 meter per second. 1 meter per second. The speed on reaching the bottom will be 1 meter per second. Once again, root of 2GL 1 minus cos theta, 2G10 L 0.1 10 centimeter, 1 minus cos theta half, 2 get cancelled 1 meter per second. Then I can calculate angular speed, that is V by R. V is 1, R is 0.1, angular speed is coming to be 10 radians per second. So I have calculated the velocity at the bottommost point. Bottommost point velocity I got 1 meter per second. It is at a distance of 10 centimeter or 0.1 meter. That made me to calculate the angular speed of that point. But I know each and every point of the rod will be of same angular speed. How much it is? 10. Now I can come to the problem. E is equal to half. B is how much? 2 Tesla. Into L square is how much? 0.1 means 10 to the power of minus 2 into 10 to the power of minus 1 square into omega. Omega is 10. That comes to be E. Induced EMF is coming to be how much? This is 10. 0.1 volt. That is how many? 100 millivolt. I think I had to check whether the answer is 100 millivolt or not. Yes, answer is so let us check whether any mistake has happened. Simple pendulum answer is given to be 10. Okay, whether we have made a mistake, look at it. Half BL square omega, look at here. B is 2T, B is 2T, not 20, 2T. It's 2 Tesla. L is 0.1 meter. Then induced EMF is half B L square. L square will be 10 to the power of minus 2 into 10 to the power of minus 1 volt. That is into 1000. That is 100 millivolt, not 10. Any mistake happened to your calculation? This is 1 meter per second. It will be omega is equal to V by R. V by R is coming to be 1 by 0.110 radians per second. Therefore, half B 10 to the power of minus 2 into omega 2 to get cancelled. Is coming correct? This is coming correct. Okay, our calculation is correct. This is a method. Answer may be different given. Okay, I think no mistake we made. Half B L squared omega, that is induced EMF. Okay, induced EMF is equal to rod rotating about 1.5 B induced EMF. This is point of yes, half B is 2 Tesla. L square is 10 centimeter, that is 0.1, correct? 0.1 B L square into omega. Omega is 10, not 1, not 1. V by V is coming to be 1. Correct, correct. Method is correct. Forget about the answer. Now, using a frequency AC voltage source of maximum current measured in given LCR series, value of L and R shown in the figure, the capacitance of the capacitor used. Capacitance of the capacitor used. Tell me, the capacitance of the capacitor is called, we are getting maximum current. When you get maximum current, omega is 1 by root LC. This is a case of resonance. Omega is given to be 100, 1 by root of L is given to be, how much you have given L? L is given to be 2 Henry into C. On solving, you will be getting the value of C. Simple question. The catch point answer is coming to be 50. The catch point is this: when voltage source, the maximum current is measured. Maximum current is measured when what happened when LCR series circuit goes to resonance. This is a case of resonance. Then angular frequency is given by 1 by root LC. Angular frequency is given to be 100. This case is angular frequency is 100. 100 is equal to 1 by root LC. L is given to be 2 Henry. So you'll be getting the answer. Okay. Going to the next question. Two separate Young's double slit experiments set up. Two monochromatic light sources of different wavelength are used to get fringes of equal width. Radius of the slit separations, the ratio of slit separations, and the wavelength of the light used are 2:1. So D1 is to D2 is equal to 2:1, and lambda 1 is to lambda 2 is equal to 1:2. We have to find, they have told that they have equal fringe width. So d1 lambda 1 by d1 is equal to d2 lambda by 2 by d2. You want to calculate d1 by d2. d1 by d2 will be is equal to small d1 by d2 into lambda 2 by lambda 1. d1 by d2 is coming to be 2 by 1, and lambda 1 by lambda 2 is 1 is to 2. So lambda 2 by lambda 1 will be 2 by 1. Your ratio is coming to be 4. Your answer is coming to be 4. Okay. Now you go to the next question, 24th question. Now tell me, yes, equation of electromagnetic wave is given to be maximum value of E0 root 37, then average power. So look here, even though they use the word average power, they use the word average power, but you see the unit, this is intensity, not watts. So you want to calculate, that's the first point, we have to calculate intensity. And intensity is given to be 1 by alpha watts per meter. That means in SI unit. That's the first thing. Then intensity, second point, intensity of electromagnetic wave propagation is given by epsilon 0 ERMS square into C. Okay. Here some tips given to you. So we have to make use of that tip. How we are going to make use of C is equal to 1 by root of epsilon 0 mu 0. You know that? So when I substitute here, I get epsilon 0 ERMS squared. Instead of C, what I can write? Root of epsilon 0 mu 0. Then this is coming to be ERMS square into this root of epsilon 0 root of epsilon 0 mu 0. Okay, this is the intensity, we already used that. But root of this, its reciprocal is 377 unit. So what is E root of 377? That is electric field amplitude. So I'm going to write it as ERMS squared, I'm writing it as E0 squared by root 2 into, I'm going to write it as 1 by root of mu 0 by epsilon 0. All of you know this change from this step to this step. How did it come? Here it was root of epsilon 0 by mu 0. I've taken it as denominator of denominator. So when it goes to the, it has become root of mu 0 by epsilon 0. Now, what is E0 given to you? 377. Its square will be root of 377. Its square will be 377 divided by root 2. Into what is the value of this? This is 1 by 377. The 377 get cancelled. We are getting intensity is equal to what? 1 by alpha. 1 by alpha is coming to be 1 by 2. So alpha is coming to be what? 2. Alpha is coming to be 2. Okay. Now we go to the next question. Now, space between the plates of parallel plate capacitor. So I'm going to divide this capacitor into 3 portions. I'm writing it within that. Now, this portion C1, this portion C2, this portion C3. Okay. Now, initially, before filling space between the plates of parallel plate, it was already a parallel plate capacitor. Capacitance was C. Capacitance was C. And what was the expression for the capacitance C? Epsilon 0 A by D. Okay. That is point number 1. Now, point number 2. Point number 2. Isn't it? This capacitance C1. C1 is how much separation? D by 2. Area A. So epsilon 0 A by D by 2 and completely filled with K1. So this is coming to be 2 epsilon 0 A by D into K1. Correct? Now come to C2. C2, separation D by 2, area A by 2. You can see area A by 2, dielectric K2. So it will be epsilon 0 A by 2 divided by separation D by 2 into K2. That comes to be 2 get cancelled. We can find epsilon 0 A by D2 into K2. Now C3. C3 will be similar. I can directly write epsilon 0 A by D into K3. Okay. Point number 2. Point number 3. C2 and C3 are connected parallelly. C2 and C3 are connected parallel. So what will be the effective capacitance of C2? When connected parallelly, we can directly write epsilon 0 A by D into K2 plus K3. Okay. Fourth point. What is the fourth point? This C1 and C2 are connected in series. C1 and C23, that's combination, are in series. Therefore, effective capacitance, I say C effective will be C1 into C23 divided by C1 plus C23. It's better to take the things common. So let us write it first. C1 will be how much? We are given the C1 here, how much? 2 epsilon 0 A by D into K1 into what is C23? Epsilon 0 A by D into K2 plus K3 divided by, we have to add it, 2 epsilon 0 A by D K1 plus epsilon 0 A by D into. So K1, C1, C23 divided by C1 plus C23. Anything common, I can take it out. Can I take it out? Epsilon 0 I by D, I take it out. Epsilon 0 A by D, I have taken out. What is left in the numerator? 2K1 plus K2 plus K3. Denominator, when I take it out, epsilon 0 A by D, isn't it? Epsilon 0 A by D, I take it out. So one epsilon 0 is here. Epsilon 0 A by D, I take it out. Here epsilon 0 A by D, I take it out. That will. So one thing. In the numerator, 1 epsilon 0 A by D, I have taken it out. Okay. What is remaining? One only came out, other will be there. This epsilon 0 A by D, we call it as C, and directly write it can C. I can write it as what? 2C K1 into K2 plus K3. Denominator, that epsilon 0 A by D, I have taken it out. Isn't it? What will be remaining? 2K1 plus K2 plus K3 remaining. This get cancelled. Now we have to use the values of K1 and K2, K3, etc. So I'll write here C effective will be 2C into K1 is how much? 2 into K2 plus K3 is 8 divided by denominator 2K1 is 4 plus K2 plus K3 8. So this is coming to be 4 into 8 into C divided by 12. 12. That is coming to be, this is 3. 8 into C by 3. So who is in place of n? In place of n, you have 8. Okay? So that will be the paper, fifth one of paper 23rd January. Okay? So next paper is following. So 5 minutes break we have. 5 minute break and നിർത്തി. Yes, students, good afternoon. We are now going to the 23rd January second shift paper. Second shift paper. Okay. 23rd January second shift paper. Question number 1. Air bubble of volume, initial volume of air bubble. I am directly writing initial volume as 2.9 centimeter cube. Isn't it? Then at depth of 5 meter. So the pressure in the liquid will be at a depth will be, that is absolute pressure will be atmospheric pressure plus H rho G. And we know atmospheric pressure in terms of that 1 atm. And you know, due to water, 10 meter of water column, pressure is 1 atmospheric pressure. That you studied. Mercury column, we require 0.76 centimeter only. 0.76 centimeter of, 76 centimeter of mercury will produce 1 atmosphere. But water, we require 10 meter. Therefore, here we have 5 meter deep. Therefore, due to atmosphere, 1 atmosphere plus due to the hydrostatic liquid half. Therefore, pressure will be 1.5 atmospheric pressure. Then initial temperature initial, that is we call P1. P1 is equal to how much? 219 degree Kelvin. Now we have to calculate what the volume of the bubble when it reaches the surface. We have to calculate volume of the bubble, isn't it? Therefore, V2 we have to calculate. Pressure when you come to the top, that is atmospheric pressure, 1 atmosphere. Then temperature at the top, it is going to be 27 degrees Celsius. Temperature at the top is 27. The temperature is 27 means 300 Kelvin. Now it is a direct formula. P1 V1 by T1 is equal to P2 V2 by T2. And they won't answer in what unit? They won't answer in, they didn't mention the unit, that is volume of the bubble. Of course, it will be given in centimeter cube unit. So we have initial volume, initial pressure calculation. We have some time saving mechanism. At a depth of 5 meter, there will be hydrostatic pressure, water pressure alone is half atmosphere. That we have to make it out easily using what concept? 10 meter of water column is corresponding to pressure of half an atmosphere. And absolute pressure will be atmospheric pressure plus. So we can work it out. I'm not going to the final answer now. Okay. Now tell me, block is sliding down inclined plane of slope, then instant t is equal to 0, the block is given. You have to say one thing, coming down with a constant speed, that is required with a constant speed. Then only we can do this problem, constant speed. Now look, here, when it is coming down with a constant speed, this block is coming down with a constant speed. So who pulls it down? Because it is told it was coming down, it's sliding down. And there is an equal frictional force. Frictional force is given to be mg sine theta. Frictional force is given mg sine theta. That is the initial moment. So it slides down, and they didn't mention that, but we have to take it, then only we can do the problem. That is, it is coming down with a constant speed. Why it is coming down with a constant speed? Who pulls it down? Gravity mg sine theta. Then as a result, there is a frictional force, equal amount of frictional force. So net force will be 0. That's why it is coming down with uniform speed. Now, second stage, we are given a velocity u, so that blocks start going up with velocity. Okay, and you know, whether it is going up or down, there will be mg sine theta down. As it goes up, frictional force also is getting down, isn't it? Earlier, when it was sliding down, frictional force was opposing the motion, mg sine theta was pulling down, they were equal, net force was equal. Okay, so I can say that initial moment mg sine theta is equal to kinetic friction force. Now Second stage, we are projecting up with velocity u. So mg sine theta will be downwards. Also, frictional force will be downwards. Therefore, second case, net force will be mg sine theta plus fk. Both are equal. So it will be 2 mg sine theta. Therefore, acceleration down the incline, acceleration down the inclined plane will be 2g sine theta. Now, initial velocity is u, acceleration 2g sine theta down. As a result, as it goes up, velocity will become 0. We can use third equation, v square is equal to u square plus 2as. V square is 0, it is told, it's stopped. U square is u square itself, plus acceleration is minus 2g sine theta, because both forces are there, minus 2g sine theta into s. We have to calculate s. So s is coming to be u square by 4g sine theta. That is the answer. U square by 4g sine theta. Okay. We go to the next question. Now, the parachute jumps aeroplane, opens the parachute after 2 seconds, free fall, and start accelerating down the height of 10 meters when it reaches. So 3 stages. This initial stage, he jumps out of the aircraft, yes, at the point A. Then, when he reaches the point B, the parachute opens. He's coming down on the parachute, isn't it? B. And he's having an acceleration opposing it upwards. How much acceleration is there? 3 meters per second square. And when it is at C, 10-meter point, he is 10-meter point above the ground, this is ground level. When he is at a height of 10-meter point at C, his velocity is how much? 5 meters per second down. We have to calculate the height of the aeroplane when he was. So, first case is a free fall. AB before opening the parachute, AB is free fall. So we can calculate the velocity when reaching the B, VB. VB is how much? GT. Therefore, we can take it as 20 meters per second. T is coming to be 2 seconds. Then distance AB he has covered. Distance AB has covered how much? Half into GT square. That also coming to be 20 meters. Now, second stage, during the motion during BC motion, initial velocity u, that is VB, that is equal to 20, that is 20 meters per second. Then acceleration minus 3, because due to upthrust, push is upward, 3 meters per second. Then velocity at C is given to be 5 meters per second. Again, use no time mentioned. Again, use third equation. Again, say V square is equal to U square plus 2S. V square is 25. U square is given to be how much? 400. Correct? Plus 2 into acceleration is minus 3 into S. Therefore, 6S, 2 into 2as, a is minus 3 into s, is equal to, this is 25. This is initial velocity was how much? 20. 20 square is 400. This is coming to be 375. Therefore, S is coming to be 375 by 6 is equal to 62.5 meter. Now, tell me, I am going to write it. AB, how many meter we calculated? 20 meter. BC, 62.5 meter. Then from ground to that point, GC, he was at a height of 10 meter. Therefore, total height from ground, how much? 20 plus 62.5 plus 10, that comes to be 92.5. Okay, answer is there. We go to the next question. Then, two charges, 7 microcoulombs and minus 2 microcoulombs, are placed at minus 2 centimeter respectively. Here, the principle we are using is, this is charges kept in an external field. Charges kept in external field. Total potential energy is given by potential at the point R1 into charge plus potential at position 2 into charge there plus self energy of the system of two charges. How much? 1 by 4 pi epsilon 0 Q1 Q2 by R. Since we have kept an external field, the total potential energy of the system will be, system is given by how much? Because Q1 is in the external potential, due to external field E, A by R squared, there is a potential at the position 1, that is phi1 is minus Q1. Then there is a potential at the position of plus 9 plus mutual potential energy of the system of the particles. These are three terms will come. Now we have to calculate the potential. Potential at the point 1 will be minus integral E dot dr, from where they are brought from infinity, isn't it, to that point R1. Isn't it? What is that? Minus integrating, we will be getting what? E's value of E is what? Or I will do the integration, isn't it? It is coming to be minus integral A by R squared dr. Isn't it? That comes to be minus into A by R into minus 1. Our power is minus 1. So this is coming to be, potential will be what? A by R. A by R. Okay. That is coming to be, A is coming to be how much? 9 into 10 to the power of 5. R is what? 9. Here there is no meaning in this minus sign, because potential is a scalar quantity. But one thing, potential due to positive charge is positive potential, and potential due to a negative charge will be a negative potential. But here, being at a minus 9 position, doesn't matter that whether it will have what? It will have minus potential. Minus potential and plus potential is decided by the charge. Plus charge will produce a positive potential, minus charge will produce a minus potential. So it will be, Vi will be A by R, 9 in 10 to the power of 9 into 9 centimeter means 9 into 10 to the power of minus 7. That comes to be 10 to the power of 7 volt. This is a potential at the position phi1. Correct? Therefore, similarly, potential at the position V2 is also 10 to the power of 7 volt. Now, I'm going to write the potential energy. Phi1 into Q1. Phi1 into Q1. Isn't it? Phi1 is how much? Phi1 potential, I mean phi1 V1 or phi1, whatever you write it. V1. 10 to the power of 7. Phi1 and phi1 is V1. Phi2 is V2. Don't be confused. 10 to the power of 7 into, what is the charge we have kept there? Charge kept is 7 microcoulomb. So 10 to the power of 7, we got it, into 7 into 10 to the power of minus 6. Isn't it? Okay. That is Q1 phi1 plus second term 10 to the power of 7 into, what is the charge? That is a minus charge. So minus 2 into 10 to the power of minus 6 plus This we call self-energy of the system. Due to the mutual attraction, they possess potential energy. That is 9 into 10 to the power of 9 into what is Q1? Q1 is 7. 7 into 10 to the power of minus 6. Q2 is minus 2 into 10 to the power of minus 6 divided by separation between them is how many? Minus 9 to plus 9, 18 centimeter, 18 into 10 to the power of minus 2. So when you work it out, you will be getting the answer as 49.3, answer getting 40. So I verified it, answer is correct, 49.3. So tell me one difference is that if you are having only two charges, Q1 and Q2, they will have only self potential energy, self energy, given by what formula? 1 by 4 pi epsilon 0 Q1 Q2 divided by separation between them. But these two charges are placed in an external magnetic electric field. Therefore, that external electric field or electric potential will produce a potential energy. In addition to that, there will be self energy. That is written here, phi1 V1 or V1 Q1 plus V2 Q2 plus 1 by 4 pi epsilon 0. Then how do you calculate V1? Integral A by R squared dr minus integral. That is the formula for electric field, potential and relation between potential, minus integral infinity to R. That comes to be 10 to the power of 7. V2 also 10 to the power of 7. Then total potential energy will be once again, V1 is 10 to the power of 7 into charge Q1. V2 is 10 to the power of 7, not minus 7. 10 to the power of 7 and its charge. That charge is minus 2 microcoulomb plus self energy. When you work it out, you will be getting the answer. Okay, I go to the next question. Small metallic sphere of diameter 2 meter, density 10 gram, dropped in glycerin having a viscosity 10 poise, then density 1. So terminal velocity. This is the direct formula for terminal velocity 2 r squared rho solid minus rho liquid into G divided by 9 eta. Now, everything given in CGS unit, the CGS unit of viscosity is poise, that is given to be 10 poise. So I am going to substitute R. Radius is how much? 2 millimeter. That is 2 into 10 to the power of minus 3. No. I want in what unit? Centimeter. That is 0.2. This is coming to be 0.2 centimeter square into densities in gram per cc. How much? 1.5 and 10.5. That is 10.5 minus 1.5 in CGS system into G. G is given 10 in CGS system. It is given to be 1000 divided by 2 into eta is given in poise. That is 10 poise. Everything in CGS system, we will be getting the value. We'll be getting the value of terminal velocity as 2 centimeter per second. You will be getting 2 centimeter per second. You work it out. I substitute everything. You can do it yourself. Now tell me. Now this question. Look, prism of angle 75 degree, refractive index √2 coated with a thin film of refractive index 1.5. It is back exit surface to have total internal reflection at the back exit surface. The exit surface incident angle must be. Now, let me draw the diagram because it's a diagram based question. There is a coating of thin coating of a material of refractive index 1.5. Yes, this given refractive index of the material is √3. This material is 1.5 or 3/2. This is less denser material. Then prism angle is 75 degree. Now, tell me, light ray undergoes total reflection from this surface. This is exit surface. I am drawing exit surface, isn't it? Light ray just undergoing total reflection from here. Yes. Okay. Tell me, this is the angle of incidence, I. This is angle of refraction at first surface. This is the angle of refraction at second surface. So it is mentioned that this is root 3. This is mentioned that it is undergoing just a total internal reflection at second surface. So I can make that R2 is coming to be critical angle. R2 is coming to be critical angle. Then number 2, sine of the critical angle is equal to 1 by rarer mu denser. Light rays coming from, this is a denser medium, this is rare, this is 1.732. Light rays coming from denser to rarer medium. So that's why it is undergoing total reflection. But in calculation of C, we want normal mu, rarer to denser mu. Isn't it? That is, we want sine C is equal to 1 by mu denser divided by mu rarer. What is that? Sine Z. Denser medium means root 3. So this will be 1 by root 3. Who will go to the numerator? 3 by 2 will go to the numerator. This is coming to be root 3 by 2. This gives you C is 60 degree. That is the first information gap. This surface, if it just undergoes total reflection, this should be 60 degree. R2 is 60 degree and R2 is critical angle. Then third point we are doing is that we know in a prism R1 plus R2 is angle of prism. Therefore, R1 is coming to be angle of prism by R2. Angle of prism is 75 degree. R2 is 60 degree. Therefore, because C is 60 degree, therefore this is 15 degree. Okay. Now we go to the, this is point number 3. We go to the point number 4. What do you have to do? We have to calculate the sine I. We have refractive index. Refractive index is me. Root 3 is equal to sine I divided by sine R1. R1 is 15 degree. Therefore, sine I is equal to root 3 into sine 15 is given to be how many? 0.25. 0.25, that means root 3 by 4. That comes to be 0.43. And it is given that sine 25 is 0.43. Therefore, I is equal to 25 degree. Yes. I is 25 degree. Now tell me, you see the options. What is option given? Greater than, less than, like that. Now tell me, just listen very carefully. For total reflection to happen, R2 should be greater than what value? R2 should be greater than 60 degree. R2 should be greater than 60 degree. Okay. In this case, total reflection will take place when angle of incidence is greater than critical angle. Critical angle is coming to be 60 degree R2. Then R2 is that. What about R1? R1 should be less than what value calculated for R1? 15 degree. And we know sin I is proportional to sin R1. Therefore, I1 should be, so how much you got? 25 degree. 25. I1 we got. So I1 should be, R1 is less than 15 degree. R1 is less. I1 is less. I1 should be less than 25 degree. And here they have given wrongly given. The mistake they made, it should be less than 25 degree. Less than, not, so you can make a correction, not more than 25 degree, less than 25 degree. Once again, I quickly go through it. You know, for total reflection to happen, just undergoing total reflection, R2, critical angle we got 60 degree, that is R2. For total reflection to happen, R2 should be greater than 60 degree. When R2 is more than 60 degree, automatically A is equal to R1, R1 is equal to A minus R2, that should be less than 15 degree. Sin I is proportional to sin R1, therefore I1 should be less than 25 degree. So option is 3, but should be less, not more than that. Okay, come on. Next, again we can directly write here. This I write in the board, I write here. We can save the time, we have done so many questions. This is what? N, we are writing N. This is Y1. Y1 is N. Y2 is this. This is set. Okay. Tell me, so what about Y2? Y2 is what? N or M. Y1 is N itself. Now we can try the options as given in the book. That will be easy without any confusion. We can try for the options given in the okay. This is N. This is M. Y1 is N itself. Y2 is equal to N or M. Then Z is equal to what? Y1 and Y2 bar. Okay. Y1 and Y2 bar. So we can go according to the options. Then only it will be helpful for you. What options are given over there? What is the option? We have 0, 0, 0, 1, 1. This is the order. Order I like. 0, 0, 0. Then next is 0, 1. Then 1, 1. Then what? 1, 0. This is the order. This we don't require. Now, and y1 is what? 0. Y2 is n, that is 0. Then y1 and y2, that will be 0, that will be 1. So 1, 1. Yes, this has got 1 correct. This has got 1 correct. One more may be there. One more may be there. It's going out. Anyway, now 0, 1. This is 0. This is OR gate. This is 1. This is again 1. 1, 1. 1, 1 coming. Yes, this is 1, 1 coming. Next, third one. 1, 1. Then this is 1. Y2 will be what? OR. OR will be 1. This will be 0. So only one option 1, 1, 0 is coming. You can select it. That will be the answer. Don't waste much time. You can go to the next time. Only one this is happening. We go to the next question. Yes. Which of the following nuclear isobars? You can directly get isobars. Same mass number. I am not wasting any time here. Directly going to the next question. Circular loop of radius 10 cm is placed in uniform magnetic field directed perpendicular to the plane of the loop. Loop is converted into a square of 0.5 EMF induced in the leaf. So here only area is changing. So again write induced EMF is equal to same magnetic field, area of circle minus area of square divided by t. Because circle has got a more area than sphere. Time is given, B is given, we have to get A1. This is what is given, radius of the circular loop is given. Therefore, A1 will be pi r squared, pi into 7 into 10 to the power of minus 2 whole square. That comes to be 49 pi into 10 to the power of minus 4. We got it. Now this is changed into a square loop. So the total length of the square loop is 4a. 4a is 2 pi r. That comes to be is equal to 2 pi r by 4. That is pi r by 2. Therefore, area A2 of the square will be pi r by 2 whole square. That comes to be pi square by 4 into radius square. Again, radius square is coming. Radius square is coming to be how much? 49 into 10 to the power of minus 4. Now we can substitute the answer and get it. I'm not doing all the steps. B is how much? 0.2 into area of circle is more. How much we got area of circle? 49 pi into 10 to the power of minus 4 minus this is near about how much? 49 by 4 near about 48. Pi square is how much? Pi square is, this is 12. Pi square is 10. This is nearly 120 into 10. This should be less. This is how much? Pi into 7 in 10 to the power of minus 4. And here it is pi by 2r whole square, a square. Pi square by pi r squared by pi square by 4. A is how much you got it? A is pi r by 2 into a square. This is coming to be 49. This is 49 pi. 49 pi. 49 pi is there. 49 pi. 49 pi into 10 to the power of minus 4 minus this is coming to be, you got it as what? There about 48, 120. 120 into 10 to the power of. And you can do one more thing. This is 0.2. This is 22 by 7. 22 by 7 means 1 7 get cancelled. 22 into 7. 22 7 means 154. This is 154 minus 120 into 10 to the power of minus 4. We'll be getting the answer. You can select the answer. Okay. I go to the next question. Now, to compare the EMFs, very simple question. E1 by E2 is equal to L1 by L2 is equal to how much? 200 and 150. Now, percentage change delta L1 by L1 plus delta L2 by L2 whole into 100. Delta L1 is going to be 1 centimeter. 1 by 200 plus 1 by 150 whole into 100. We'll be getting the answer. Okay. Next, 14 kilograms mattress explodes and breaks into 3 fragments of masses in the ratio 2:2:3. So M1 is to M2 is to M3 is 2:2:3. Therefore, M1 will be total mass is 40 into 2 by 7. That comes to be 4 kilogram. Similarly, M2 is same. That is also 4 kilogram. Therefore, M3 will be how many? 4 plus 4, 8. That is 6 kilogram. We got it? Now tell me, this equal masses will move in mutually perpendicular direction with what speeds? It speeds 18 meter per second. So its momentum will be 18 into 4, 72. This also 72 Newton second. Then its resultant will be along its angle bisector. How much it will be? It is coming to be 72 into root 2. So third fragment should move in such a manner that it should oppose the momentum of this. And what is the momentum of third fragment? Its mass is how much? 6 kilogram into its velocity. So what you can write? 6 into V is equal to 72 into root 2. And then V is coming to be 12 root. I got the answer quickly. This is the answer, 12 root 2. Okay. We go to the next question. Now, current passing through a conducting loop in the form of an equilateral triangle, 4 root 3 centimeter, 2 ampere. Magnetic field at the centroid is this value of alpha. This is a standard thing. Many students remember the answer. Many students remember the answer. This is an equilateral triangle. Equilateral triangle. Okay. Yes. This is the centroid. In the calculation, this is our R. Due to one side, I write B1 due to one side. Due to one side, B1. B1 is given by mu 0 I by 4 pi R sine phi 1 plus sine phi 2. You know, R is the distance from vertex to the center. This will be an equilateral triangle. This will be 30 degree. This will be 30 degree. Your phi 1 will be 60 degree. Your phi 2 will be 60 degree. And distance from centroid to the base will be A by 2 root 3. That's a basic result. Distance from vertex to centroid is A by root 3. Center to the base side is equal to A by 2 root 3. Your A is coming to be how much? 4 root 3. 4 root 3 centimeter. 4 root 3 into 10 to the power of minus 2 divided by 2 root 3. That comes to be 2 into 10 to the power of minus 2. Now, magnetic field will be 4 pi into 10 to the power of minus 7 into I will be 2 ampere divided by 4 pi. R is given to be 2 into 10 to the power of minus 2 sine 60 plus sine 60. Sine 60 plus sine 60 is what? Root 3. Then we'll be getting the answer. Answer is coming to be, yes, here 3 root 3. Answer is coming to be 3 root. This is the correct answer. You can work it out. I have done up to last step. Simple substitution only we require it. I go to the next question. Ratio of the speeds of electromagnetic waves in vacuum and in medium having dielectric constant K and permeability mu, relative permeability. Mu is 2 mu 0. So first I am going to ask it, mu is equal to mu 0 mu r. That is given to be 2 mu 0. That gives you mu r is 2. Then we have to calculate ratio speeds in vacuum. In air or vacuum divided by medium is equal to 1 by root of mu 0 epsilon 0 into cross multiplication. Root of mu 0 mu r into epsilon 0 by r. Therefore, velocity in air divided by velocity in medium, mu 0 get cancelled, root of mu r into epsilon r. Mu r is given to be 3, epsilon 0 is given to be what? 2. This is coming to be root 6 is to 1. Answer is there, second answer. We go to the next question. Okay, when unpolarized light of particular angle placed in air is observed that reflected beam is linearly polarized. This happens when when tan of the polarizing angle is equal to mu, isn't it? And it is given that polarizing angle refractive index of air and glass are 1.0 and 1.52. So it is given that mu is 1.52. This gives you that angle of incidence is polarizing angle 57.7 degrees centigrade. Then, what is the question asked you? Then I plus R, IP plus R is equal to 90 degree. Then angle of refraction is equal to 90 minus IP. That is equal to 90 minus 57.7 That comes to be 32.3. So answer is very, some questions are very easy, but this question of polarization is asked many occasions, many occasions. This question of polarization. And when light is incident at any angle, reflected light is partially polarized, number one. Number two, at a polarizing angle, it is fully polarized. That at polarizing angle, reflected and refracted rays are mutually perpendicular. IP plus R is 90 degree and tan of IP is equal to mu. Okay, come on. We go to the next question. Internal energy of monatomic gas is 3 nRT. Generally, it is 3 by monatomic gas, but we take it as 3 nRT. No problem. Yes, it is given. So we are going according to the given question. Yes. 1 mole of helium is kept in a cylinder having an internal cross-section area 17 centimeters squared, fitted with a light movable piston. The gas is heated slowly by supplying 126 joules of heat. Then temperature rises by. So let me calculate change in internal energy 3 nR dt. N is 1, let it be in R, dt is 4, that is coming to be 12R. Heat supplied is given to be how much? 126 joules. Then work done is given to be delta Q minus delta U, that is 12R. 126 minus 12R. 126 minus 12R is coming to be nearly 8.3, nearly 100, nearly 26, nearly approximate calculation you can do, 26 joules. Now, as a result, the piston goes up. At what pressure? Atmospheric pressure. Therefore, work done, we calculated here work done as 26 joules. We can also calculate the work done by this formula, pressure into change of volume. What is pressure into change of volume? Area into displacement happening to the piston. Then pressure is given to be how much? How much? 1 atmosphere, 10 to the power of 5. Area is given to be area of the 17 centimeter square, 17 into 10 to the power of minus 4 into delta x. This is coming to be 26. And solving, you are able to calculate the value of delta x, and answer is coming to be, delta x is coming to be, with answer, delta x is coming to be answer, I think not available in the options. Just you tried, I have given the values. This is the answer. 10 to the power, this will be 117, delta x is 26. From that you are able to calculate 26 by 170, that is coming in terms of meter. You are asked in terms of what? Centimeter. So into 100. Okay, you try it. You will be getting that. You may get the answer. Try it. Now here, one bead is moving with a steady speed. Here, initially its speed was this, and as it comes down, its speed is first decreasing to a maximum value. Then from maximum value, it decreases. So during the motion of ACB motion, average speed is more than the speed of what? This bead. It is given that another bead Q, same mass P, is ejected at T0 along the horizontal AB with a speed V. Okay, and initial speed of the P is also what? Initial velocity V. So its speed will be increasing and then decreasing to that same value V. But as an average, during the whole motion as an average, its velocity is more than V. Its velocity is throughout V. Therefore, this have an average velocity more than V. Time taken will be less. Therefore, TP is less than TQ. Next question. I'm leaving it because it is very lengthy question. So it will be taking a lot of time. So for time being, I left it. I go to the next question. 18th question. 1 mole of an ideal diatomic gas expands from V to 2V isothermally at a temperature of 27 degree. Work done. So first case, isothermal expansion. We have the formula for work done. What is the formula? Mu RT log of V2 by V1. How many moles? 1 mole. R, let it be R. And T is how much? At what temperature? 27 degree. That is 300. And log of V2 by V1. V2 is 2. Log 2. Log 2 is given to be nearly 0.693. Log 2. That is nearly 0.7 into 300 R. That comes to be 210 R. This is work done in what process? Isothermal process. In adiabatic process, work done is given by mu r divided by gamma minus 1 into T1 minus T2. Okay, but T1 is with you. T2 you have to calculate using what formula? T2 into V2 to the power of this then final temperature. You have to calculate this. We don't calculate final temperature only. T2 you don't calculate. T2 only. It is given that if the gas undergoes same magnitude expanded adiabatically and by doing same amount of work, both the works are equal. This work and this work are equal. Therefore, what you can write? Mu1, R let it be there. Gamma minus 1, what gas? Diatomic gas. Gamma is 1.4. 1.4 minus 1.4 into T1 is 300 minus T2 is equal to there R into log 2 I told let it be in yes, 210 R, I got it, 210 R, correct? So this is the work done in adiabatic process, mu R by gamma minus 1, that is 0.4 into T1 is 300 minus T2 you have to calculate into work done in isothermal process, mu RT log of V2 by V1, that is coming near about, putting log 2 is 0.7 into 300 R, that is coming to be. Now, RR get cancelled. 300 minus T2 is coming to be 210 into 0.4. That comes to be 84. Therefore, T is coming to be 300 minus 84. That is 216 Kelvin. Therefore, temperature in degrees Celsius will be 216 minus 273. That is coming to be 57 minus 56, near about 56, 57. Yes, minus 57, 56, nearly 56 degrees Celsius. We want it close to that. So answer is that. Okay, come on. Now, next question. There are two dipoles. We'll draw another diagram. This dipole B, dipole A, dipole B is plus minus. And this is their midpoint. P is midpoint. And this dipole A, this is minus, this is plus. Minus and plus. Okay, come on. Now look, due to this dipole A, and let me calculate dipole moment of each. QA dipole moment, I say dipole moment PA. PA is no, they are different. Values are 4 microcoulomb. B it is 4 microcoulomb. PA will be either of the charge into separation between them. What is separation between the charges given to be how many? Length 1 centimeter. That is 10 to the power of minus 2. Therefore, dipole moment is given to be 2 into 10 to the power of minus 8 coulometer. And PB, dipole moment is given to be 4 charges, to be just double, 4 into 10 to the power of minus 8. So PB, due to the second dipole, 4 into 10 to the power of minus 8 coulometer. Now, due to that, the charge is kept on the equatorial line. Then electric field is given by anti-parallel to the dipole moment vector. This is the electric field due to B. And due to this, electric field is along the axial line from negative to positive. This is the direction of electric field. EA and DB. So let us calculate EA. EA is equal to how much? 9 into 10 to the power of 9 into 2 into, what is the dipole moment? 2p, that is 2 into 10 to the power of minus 8 divided by r cube. R is how many? 80 centimeters. 80 centimeter means half will be 40. This distance is 40 centimeter. This is also 40 centimeter. So for this is 0.4. 4 in 10 to the power of minus 1. It's cube, r cube. Field is r cube dipole. So it will be 64 into 10 to the power of minus 3. EB will be on equatorial line. Their field is 9 into 10 to the power of 9 into P by R cube only. This is 2P by R cube. This is P by R cube. But P's value is double. Therefore, this is also 4 into 10 to the power of minus 8 divided by distance, same distance, 64 into 10 to the power of minus 3. Got it? Both fields are equal. EA and EB are equal. Therefore, you have to work it out. That's only. Therefore, resultant field will be EA root 2 or EB root 2 because EA is equal to EB. Yes, we can work it out from this. I think answer is coming to be, how much answer is coming? 3 is the answer coming. 3 is the answer coming. Now come to the parallel plate capacitor, question number 20. A parallel plate capacitor of separation 5 millimeters charged by a battery on reducing a mica sheet of 2 millimeter and maintaining the connection to the plate with the terminals of the batteries not changing. It is found that it draws 25% more charge. Now tell me, initial capacitance C is equal to epsilon 0 A by D. D is 5 millimeter. D is 5. Let it be in millimeter. I'm not converting it. Then, when you are introducing a dielectric slab of how much thickness? 2 millimeter. This is dielectric of dielectric constant K, 2 millimeter. And we are going to use, we are comparing a dielectric capacitor like an air capacitor. And for that, we are calculating effective air separation, to find initially completely air. So I have this formula epsilon 0 A by D, where D is what? 5 millimeter. Now to find effective air separation, Look, how I'm calculating. Actual air, everybody. Actual air, how much? Effective air separation. What is actual air? Actual air. Now, it is not 5 millimeter. Why? We have introduced a dielectric slab of thickness 2 millimeter. So, that region is devoid of air. So, actual air will be 5 minus 2, that 3 millimeter. Then, equivalent air. Equivalent air. I use the word equivalent air. There I am introducing d thickness of a dielectric. This concept, d thickness of the equivalent air is equal to thickness of dielectric divided by dielectric constant K. That very useful substitution for us. We are converting dielectric into air. How do you convert equivalent air? Dielectric is taken as an equivalent air. How do you take equivalent air? Actual dielectric thickness divided by dielectric constant. So, equivalent air will be 2 divided by K. So, actual 3 millimeter is there, equivalent 2 by K is there. Now, I use the word effective air. Effective air is, actual air is 3 plus equivalent air 2 by K. Now, instead of considering as a dielectric, partially filled dielectric, I consider it as an air dielectric of effective air thickness is actual air thickness plus equivalent air thickness. Actual air thickness is 3 plus 2 by K. So now what will be the new capacitance C dash? Epsilon 0 A divided by 3 plus 2 by K. Correct? Now, here we are connecting to the source of EMF, still connecting to the source of EMF V in both the cases. So, potential difference will not change. Q will be changing. First case, what is Q? What will be Q? Q will be C into V. What is C? Epsilon 0 A by D. So, how many? 5 millimeter. It will be in millimeter. Into V. V, whatever it may be. Second case, Q dash. Q dash will be how much? Epsilon 0 A by 3 plus 2K into V. Yes. Then what happened? It draws 25% more charges. That means, what it means? Q dash is more. How many times more? Q dash, second case, when filled with the dielectric, it can store 25% more charge. What is the meaning of 25% more charge? New charge will be how much? 1.25 times. So once again, how do you calculate charge? Charge is equal to C into V. V same in both the cases. Isn't it? First case, C is epsilon 0 A by 5. Second case, epsilon 0 A by 3 by, not 2K, 2 by K, 2 by K. 2 millimeter of dielectric is equivalent to 2 by K, 2 by K thickness of A. Now Q by Q dash, Q by Q dash, Q dash by Q. So what will be Q dash by Q? Epsilon 0 V get cancelled. Epsilon 0 V get cancelled. Who will be there? Will go to the numerator. 5 will go to the numerator. 5 will go to the numerator. Then who will come in the denominator? 3 plus 2K will come. This is coming to be the 1.25. Then cross multiplication will be getting what? 5 is equal to, this is 3.75. 5 is equal to 3.75 into plus how much? This is 2.5. 2.5 by k. Therefore, 2.5 by k is equal to 1.25, and k will be getting 2. K will be getting 2. 2.5 by 1 point. Answer is there? Yes, very much. First answer is 2. Okay, we go to the next question. Now, suppose there is a uniform circular disk of m kilo. This axis, you have to make it, the diagram is not giving the axis is passing through the center and perpendicular to the plane, not along the diameter, not along the diameter. Better I draw the diagram like this. This is the case of diagram. Like this. So, we are removing two discs touching the periphery, wherever it may be, doesn't matter. That angle doesn't make, because all are equal distance, how much? R by 4 and 3 by 4 R. This distance from center to center is 3 by 4 R. Its radius is R by 4. Radius of this is R by 4. This is also 3 by 4 R. To the, from here O to the center, its radius is also R by 4. And these two are removed. Yes. Okay. Now we know the mass is distributed, this is a disk, mass being distributed area wise. As mass being distributed area wise, we can find out that mass of removed portion, array small a, that is proportional to area. Compared with the big disk of radius, its area is how much? 1/16th only. Radius is R by 4, area will be 1 by 16. So mass will be m by 16. Mass distribution is area wise. Radius is 1/4, area is 1 by 16. Mass of each removed portion will be, that is m1 is, that is a m1 is equal to m2 is equal to m is equal to m by 16. Okay. Now, what will be the moment of inertia of each removed one? I say I1, moment of inertia of that. That is that I1G plus md squared. Very careful you have to do. I1G, because we want that this is my axis. But so I had to shift the axis. I had to use parallax theorem. I want moment of inertia about its central axis, that is I1G plus md square. Tell me, I1G is what? This is the disk about central axis, that is mr squared by 2. mr squared by 2. I'm directly writing without wasting time. M of that portion will be capital M by 16 into R will be R by 4, that is R squared by 16 into 1 by 2, half M R squared. That is I1, half M by 16 into R by 4 whole square. This is I1G plus M by 16 into distance is 3 by 4 R. That will be 9 by 16 R squared. So tell me what I can take it out. I can take it out mr squared by 256. I can take it out. What will be removing? 1 by 2 plus 9. Correct? 1 by 2. This is m by 16 into 9 r squared. Okay. That is, we got it, I1. Now, 1 by 2 m by 16 r squared by 4. Correct? mr squared by 256 into 1 by 2 is here. M by 16 mass into distance is 3 by 4 whole square. That is equal to 18 plus 19 by I2 is same thing, same value. How much? mr squared by 256 into, this is coming to be 19 by 2. Okay, I1 and I2. Ini before removal, moment of inertia is I. This is a disk about central axis. Mass of disk is m, radius is r, mr squared by 2. Okay. Therefore, moment of inertia of the remaining figure, I minus I1 plus I2. I is what? Capital MR squared by 2. Then I1 and I2 are equal. Both are equal. Therefore, what will be sum of them? Sum of them will be, yes, I can get it as MR squared by 256 into 19. Because 19 by 2 plus 9, this is also what? MR squared by 256 into 19 by 2. So 19 by 2 plus 19 by 2 will be 19. Then subtracting, what will be, who will be coming out? Yes, MR squared by 2 will be coming out. 1 minus 19 by 256. That is 256 by 19. Any answer coming? Yes, this is coming to be answer I will give you. Answer is coming to be nearly 109. 109 is coming. What is, we have to calculate here? X, oh yes, X is there. This is coming to be 109. This is 19 by 2, anything missing? MR squared, 2 is here. So it will be coming to be, I will do it, MR squared by 256. This is coming to be 256 minus 19. 256 minus 19. 256 minus, okay, you will be getting the value. This is asked from you. That is X value. 256 by, I think it is 109 coming. You find it out. Okay. Calculation is small. Then size of an image object found by thin lenses are equal. Object is placed at two different positions, 8 centimeter. Now tell me, this is a convex lens. One image is magnified image. Other image is diminished image of same magnification. So M1 is, one is minus M, that is real image. M2 is equal to M, virtual image. For getting virtual image, this real image, you should be more than focal length. So this should be more. You should be minus 24. Second case, you should be minus 8. And for a lens, we have ready-made formula for magnification, F divided by F plus U. Lens. Mirror is F divided by F minus U. This is F divided by F plus U. First case, what is M1? M1 is what? Minus M is equal to F divided by F minus 24. Isn't it? Second case, plus M is equal to F divided by F minus 8. So what to do? We are let the minus to go this side. So we can write it as like this. This gives you M is equal to F divided by minus of F minus. Here M is equal to F divided by F minus 8. Both the denominators I can equate it. I will be getting minus F plus 24 is equal to F minus 8. This will be coming here. That is coming to be 2F is equal to 32. That gives you F is equal to 16. Okay, F will be 16. We go to next question quickly. What is that? Velocity of sound in air double. We know that V dash by V is equal to T dash by T. P dash by D is double. T dash, then what value at 0 degree centigrade? It is 273. T dash is coming to be 273 into 4. That is coming to be 1092 Kelvin. It is a very standard result, and in different, it will be 819 degrees Celsius. We go to next question quickly. Then energy release per fission for the nucleus of uranium. Fission of one atom, one fission, one atom, how much energy? 190 MeV. Then we know 235 grams of uranium contains Avogadro number, Na. How much it is? Nearly 6 into 10 to the power of 23. Therefore, 1 gram contains 6 into 10 to the power of 23 divided by 235. Therefore, 47 grams, how many? 6 into 10 to the power of 23 divided by 235 into 47. This many number of atoms. And I think this is divisible. How many times? Exactly 5 times. Therefore, 6 by 5, 1.2 into 10 to the power of 23 atoms. One atom, how much energy? Fission of one atom. One atom fission, we get 190. Therefore, total energy released from 47 grams, how much it will be? 1.2 into 10 to the power of 23 into how much? 190 MeV. Isn't it? 190 MeV. Okay. So that is coming to be 190 into 1.2. 190 into 1.2 will be nearly 228 into 10 to the power of 23 MeV. And it is given to be how much? How much? Alpha into 10 to the power of 23 MeV. Therefore, alpha is coming to be 228. Okay? Yes. So alpha we got it. Okay, I think last question we are coming. What? Ball of radius or density rho and dropped through a viscous liquid. And we know time is given by a constant density to the power of A, radius to the power of B, coefficient of viscosity to the power of D, sigma to the power of D. But there are 4 variables. We are equating dimensions of mass, length, and time. We can solve only 3 equations. But here 4 variables are coming. What are they? Rho, sigma, and one interesting thing we can find here. What is that? Sigma is also density of liquid. Both are densities. Therefore, power of A and power of D are equal. Because both are density. One is solids density, other is liquid density. In the language of dimension, that doesn't have any difference. So we don't involve 4 variables. We involve only how many variables? 3 variables. D can be replaced by A, because A is a power of density, D is a power of density. So instead of D, what I can write? A. So what I can write now? T is equal to, I'm changing into dimensional formula. So it will be T to the power of 1. T to the power of 1. A has no dimension. Density m L to the power of minus 3 into A, R L to the power of B, eta m L minus 1 T minus 1 to the power of C, and again D is what? A only, so I can write again m L minus 3 to the power of A. Both are same. Both are same. Now equating first only one term containing time, I can get for time. For time, we'll be getting what? Minus C is equal to 1. C is equal to 1, minus 1. Similarly, calculate for M. M is coming to be how much? M to the power of A, M to the power of A. That is 2A plus C. 2A plus C, because this is M to the power of A, M to the power of 2A plus C is coming to be what? 0. Therefore, 2A coming to be minus C, A coming to be minus C by 2. C is minus 1, minus of 1 by 2. A is coming to be 1 by 2. Now, for length, power B, I can equate what? That is minus 3A plus B. This is for mass. Isn't it? And this is for length. Minus 3A plus B, then again minus 3A, that comes to be 0. Am I correct? Here minus 3A plus B, C is coming. Minus 3A minus 3B minus B minus C minus 3A is equal to 0. This minus 6A, A is half, plus B, C is minus 1. Minus 1 will become plus. This is 0. This is minus 3 plus B plus 1 is equal to 0. This is coming to be B is equal to how much? Minus 3, that will go 3. 3 minus 1, 2. So we got all these values. C is minus 1, A is plus half, B is 2. Only 3 variables here, A, B, C. Now what do you have to calculate? B plus C. What is B? 2. C is minus 1. B plus C. B plus C is 2 minus 1. A plus D. A and D are equal. We have to A is equal to D. This is 2D. What is the value of D? D is coming to be, or A, not A plus D is 2A or 2D. Both are same. A and D are equal. Is equal to A plus D is equal to 2A. And what is the value of A? A is coming to be half. This is 2 minus 1 is 1. 2A is equal to 2 into half. That is also 1. Therefore, B plus C divided by A plus D is coming to be 1. Okay? Yes. This is all about in our. So we have completed January 23rd session 1 and session